Hello, class, and welcome to week 3. I wanted to go over the lab that you will be doing for this week, and this week's lab is on limiting reagents. For this particular lab, you will be working with balancing chemical equations and using those balanced chemical equations to do what we call stoichiometry. And stoichiometry is where we do conversions from, say, grams of one substance to grams of another substance in a balanced chemical equation, and we use the coefficients to represent the number of moles of that substance. And so if we look at this first equation where we have hydrogen gas plus oxygen gas producing water as a liquid, these numbers that are in front of the H2 and the H2O, those are those coefficients. If there's no number written like you see here for oxygen, then the number is understood to be 1, and we don't write the ones. Excuse me. If we look at the next equation, we have sodium chloride, which is aqueous. An AQ represents aqueous, the G represents gas, L is a liquid, and then here you see an S for solid. That tells you the phase of that substance. Then we have silver nitrate, which is aqueous. Produces silver chloride, which is a solid, and sodium nitrate, which is aqueous. This equation is balanced, and so you don't have coefficients here, but we know that those coefficients are ones, right? And so knowing how to balance your chemical equations, very important for not only this lab, but also for this week and moving forward. So if you have questions on how to balance equations, please let me know. I will go over one of the stoichiometry calculations to give you a heads up so you know how to do it. And so the procedure for this lab, we will be again working with the virtual lab. And so if you need a quick tutorial on how to use the virtual lab again, make sure that you look at that link on the homepage. I also have a link for a tutorial that I did on the homepage as well. If we want to bring up the lab for this week for limiting reagents, you just want to click on this, but you want to hit Control and then click on it, like it says here in the box. So you hit Control and then you're able to click on it and it'll come right up. But I'm going to go through it. I already have it brought up. Okay. So at this point, you have prepared the laboratory for the first experiment with the required supplies to complete the experiment. If you haven't already done so, formulate a hypothesis about the stoichiometry of the reaction between sodium chloride and silver nitrate, as you will need to include this in your final lab report. Remember, in your final lab report, first of all, any calculations that you do, that does need to be in the results section. Your hypothesis, remember that needs to be in your introduction section. And so there are some questions down here that deal with trying to figure out the number of grams that you need and the moles and the conversion. We're going to go over those, but I do want to go through, first of all, the procedure for what you'll be doing for today. So you're going to select the Solutions tab in the stockroom and then select the Erlenmeyer flask containing 1.0 grams of sodium chloride to move it to the workbench. We will now collect some data about the solution in the information pane, record the values from the concentration, molarity for the sodium and the chlorine ions in your notes. Before moving to the next step, you will need to calculate the number of grams of each species, record the calculations and resulting answers in your electronic or handwritten notes, and then return to the solutions table in the stockroom and obtain Erlenmeyer flask containing the 1.00 grams of silver nitrate. You want to add 100 milliliters of water to the flask. And remember, in real laboratory setting, you cannot accurately add small volumes of water from a very large container. So you will need to transfer small aliquot aliquot of water to a beaker or other piece of glassware before transferring the required amount to the flask. The term aliquot is pronounced aliquot and is typically used to describe small samples of a whole in a chemical analysis. All right, so let's look at it so you see what all of that is looking like. All right, so first of all, in your modules under week 3, the procedure is listed here underneath laboratory. The week 3 laboratory is where you're going to put your lab report. That's your Dropbox. But this is what's going to come up when you click on that link. And so you see here in the stock room, in under solutions, you have your water, you have your sodium chloride, and you have your silver nitrate. And then down here, you have your 1.0 gram sodium chloride. And so if we move that here, you will see all the information for your species that it talked about in the lab. So this tells you your molarity of the sodium ions, your molarity of chlorine, and then the temperature as well as the pH. Okay, grams, I think you calculate. All right, and so it's 100 grams of sodium chloride and 100.34 milliliters is your volume. Okay, and so if we go back to the stock room and we can, oh wait, go back to the stock room. We can bring over the 1 milliliter of the silver nitrate and we can get the information about that. Oh, there it goes. Okay, it does do it. All right, so you just have to play around with it and click it the right way because it will come up and you can change your units there. If we go back here, okay, there it goes. All right, so now you have the grams of your sodium, the grams of your chlorine. All right. And so if we look in the stock room, we can move our water over. And anytime you bring something over, you can always move it around your workbench. It doesn't have to be stacked on top of each other. And so if you're wanting to get some water out, you want to first put it into a beaker. Okay. And so you put the beaker, oh, wait a minute. No, there we go. You put the beaker over, I'm sorry, you put the jug of water over the beaker and then you can tell it how much you want it to pour. So say we want to pour 50 milliliters, and so it does that and you're good to go. So we can close this out. All right, so now we have 50.00 milliliters of water in there, and then you can transfer it from that to your graduated cylinder. All right, I'm just doing this as an example so that you see how to do it. Okay, there we go. And say we don't want to pour all 50. Say we want to only pour 25. So you can be precise, you can do it realistically and actually pour it, or you can do it to significant figures, but we're going to do precise just for this demonstration. And then it will show you how to read it. All right, so when you're reading volumes, you always want to read the bottom of this, what I call a smiley face, but it's a meniscus. And it is formed because of the way the water attracts to the glassware. And so you want to read the bottom, okay? And so you'll see that if you read the bottom, that bottom number is somewhat, it's not exactly 25, it's like 25 and maybe a half. Okay, but it depends on how you read it. And you can always say if you didn't get that or if you didn't do it right and you want to remove the liquid, you didn't pour it correctly, you can always remove that liquid, okay? If you want to remove anything from your lab bench. So you can always click on what you want to remove and it will go away. Okay. And say you have a lot of things on your lab bench and you just want to clear the workbench. you can just clear it off. Okay, so you know that that tool is available to you. All right, so you can kind of play around with that and follow the directions. It will tell you exactly what you need to do. And then if you have questions about the lab, then let me know. What I do want to show you is an example of the stoichiometry calculation so that you can know how to do that. And so I am going to do this one right here. Okay. All right, so it says the solution labeled solution 1 in the stockroom contains 2.00 grams of NaCl. How many grams of AgNO3 must be added to the solution to completely react with sodium chloride according to the reaction in the background section? All right, and so when you're given a stoichiometric problem and you're trying to compare grams or moles of one substance to grams or moles of another substance that are in the balanced chemical equation, the first thing you want to do is make sure that your chemical equation is balanced. So we're going to look back at the equation. Let me take the annotation off so that I can scroll up. All right, there we go. And so looking at the equation, okay, we see that everything is balanced. We have one sodium on both sides, one chlorine on both sides, one silver on both sides, one nitrogen on both sides, and three oxygen on both sides. So we know it's completely balanced. And if we look, that all the coefficients are 1. So that means we have 1 mole of sodium chloride for every 1 mole of silver nitrate, AgNO3. And so we're going to need that for our equation. And so let's do the equations. Let me get my pen back. All right, so now we're going to take 2.00 because we always, oops, no. We don't want that. Okay. We don't want shape. We just want, okay, we don't want that. Let's see if this works now. All right, bear with me. There we go. Using this for the first time. Okay, that's too big. All right, I'm gonna get this right eventually. Okay, no. Okay, there we go. All right, so we are starting off with, always want to start off with what you're given. And we are given 2.00, and that's grams of the sodium chloride. All right, so we want to go from grams of sodium chloride to moles of sodium chloride. And to do this, we're going to use our molar mass. So how do we get that molar mass? We are going to use the mass that's in the periodic table. All right. And so for sodium, all right, there we go. All right, so for sodium, sodium has a mass of 22.99, and that's just the bottom number that's listed in the periodic table for Na. So 22.99, and we're going to add that to the mass of chlorine. So the mass of chlorine is 35.45. And generally I go two places after the decimal. It just makes it nice and easy. All right, so 58.44 is what we get for the mass of sodium chloride. Remember, we're just adding sodium to chlorine's mass, and that's grams. Okay. Now, we want to go from moles of sodium chloride to moles of silver nitrate. And like we said before, it is 1 mole of silver nitrate for every 1 mole of sodium chloride. MOL is the abbreviation for mole. Okay, and 1 mole sodium chloride. Okay. So now we want to go from moles of sodium chloride to grams of sodium chloride. And so, all right. So one thing I want to mention, we started with grams. So we know that grams have to go to the bottom because we want our grams to cancel. So that makes moles go on the top. We have moles of sodium chloride on top. So that means in our next conversion, we want moles of sodium chloride to go on the bottom. We have moles of silver nitrate on top. So on this next conversion, we want the 1 mole of silver nitrate to go on the bottom. And I'm gonna put NaAgNO3. Ooh, that is a G. Okay, let me make that look more like a G. There we go, that's better. All right, so for the grams, we're again looking at the periodic table. For silver, we have 107.9. And then for nitrogen, we have 14.01. For oxygen, there are 3 oxygen, and we need to take 3 times 16 for that and then add it. Okay. So when we do the math for that, we get 169.91, and that's grams. And it would be grams of silver nitrate ran out of room. All right. So now let's look at what cancels. So the grams of sodium chloride cancel, and the moles of sodium chloride cancel. And we're only canceling units. We're not canceling numbers. Okay, with the moles of that. All right. So we're left with grams of silver nitrate, and that is what the problem is looking for. Grams of silver nitrate. So we know that we set up the problem correctly if we end up with the correct number of units. So now it's just a matter of calculating. Everything that is on top of the line, we're going to multiply. Everything on the bottom, we divide. The ones, if we multiply or divide by 1, it's still the same answer. So we have 2, we're going to divide by 58.44, and then we're going to multiply by 169.91. With multiplication and division, it does not matter the order, okay? You will still get the same answer. But what we do need to pay close attention to is significant figures for our answers. The ones we don't look at for significant figures, so we're looking at the 2.00, which has 3, 58.44 has 4, 169.91 has 5. Remember, you always want to go with the least when you're multiplying and dividing. So the least would be 3, and so our answer would be 5.81, and that's grams of silver nitrate. Okay. And so anytime you're doing stoichiometry, very important that you keep track of those units because that's going to tell you if you're setting up your problem correctly for this particular calculation. And you always want to get that set up great. Okay. And so 5.81 grams of silver nitrate would be your answer to problem A. All right. And so that will be the amount to completely react. For part B, I'm going to let you do that on your own, but I'm just going to read it. So the solution labeled solution 2 in the stockroom contains 3.00 grams of sodium chloride. If excess sodium chloride is added to the solution, how many grams of silver chloride solid will be formed? Okay. And so your silver chloride, just want to give you a heads up, okay, is on the product side. So silver chloride is the product side. Now you're looking at how much is produced. And so you always want to look at your limiting reagent to tell you which one is which one is going to produce the silver chloride because you can only produce as much as your limiting reagent will allow. Okay, so I just want to give you a heads up on that just to give you a quick hint on how to solve that problem. All right. But if you have questions, let me know. So let me erase what is on my screen so that I can show you the rest. Let me see if we can get it to erase all. Or maybe if I do that. Yep, clear all drawing. There we go. All right, so now let's see what else is on here. So the rest of the information's on here is the report requirements. I do want to go back over this because just to reiterate what all should be included in your lab report. So your title page, that's on a separate page. You have the title of the laboratory experiment, which in this case is limiting reagents, your name, the course and section number, and the date. Very important. That's on its separate sheet. You can center it in the sheet. And you also want that double spaced as well. Remember, your entire lab report is going to be double spaced. You want to make sure that you're using Times New Roman for your font, and you want to make sure that you're using 12 point, okay? You want a 1 inch border on all sides. So then your introduction, that goes on your second page. You want to have this label before you start typing in your introduction. So have a label that says introduction, and then you're going to type in the information. So while the laboratory background for each experiment lists some rudimentary, information, this will not be enough to complete the introduction. So you want to find other information. You'll use a source. Find a source about limiting reagents. You can use your textbook. Just make sure that you have the reference that is included. And so you want to have your hypothesis in this introduction, all right? Make sure that you don't plagiarize, okay? Very important. If you are using some source, okay, whether it be a source you found on an AI source or just a source that you found on your own, whatever the source may be, make sure that you reference it. Okay, you want to reference it. Otherwise, it is considered plagiarism. Very important. All right, and you want to paraphrase it. Okay, you don't want to quote it directly, but you want to paraphrase it. You want it to be in your own words, okay? Because this is your lab report. You want it to be in your words, all right? And then methods and materials. So what equipment did you use for the lab? Okay, all the equipment, but I don't want it just listed. I want to write it written in paragraph form, okay? This is a lab report. We don't just list things out. We want to write those in paragraph form. Any laboratory equipment that you used, you don't have to include your computer setup and all of that, but you do want to include your glassware. You want to include your solutions that you use, your procedure. You want to discuss what you did in the lab. Okay. Then the results section, that's going to be your charts, your tables, that's all your calculations. You want to show samples of your calculations. You can do those through Word. Okay. So if you, um, want to know how to insert a calculation, I may do a video on that. But you want to insert your calculations, or you can write them out and you're included in your report. You're going to include it as a figure in your report. Okay, very important. But you want to make sure that all of your lab reports have calculations. And then you want to label your figures, okay? And when you reference them through that figure, okay? Because you're learning how to do scientific writing. So this is where you're learning the initial parts because you're going to need this for Chem 2, you're going to need this for organic. Any type of scientific writing that you need to know how to write a really good lab report. All right. So then the discussion. This is where you discuss what your results were. Does it prove your hypothesis? If it doesn't prove it, why not? What um what could you do differently, or how could you reword your hypothesis so that it better matches your experiment? Okay. So those are the things that I'm looking for in the discussion. I'm also looking for, did you satisfy the objective of the lab? Okay. How do your results affect the theories you discussed in the introduction? Do they confirm or disagree? What aspects of the experimental environment could have confounded the results? Were there errors in the experiment? What things could you do differently moving forward? Okay, all of that is in your discussion section. And then the last page, which is also on a separate page, is the references. You're going to reference all of the sources that you used, okay? You're going to reference them on this separate piece of paper. There should always be a reference. If you don't use any other reference other than these lab instructions, okay, then you want to reference that, okay? If you are referencing the book, you want to reference the book. So very important. There should always be at least one reference on every lab report that you do for this class. So anytime you have questions, please let me know. Have a great day.